Okay, so this is the same general chart, general BCA chart that I handed out to you with your stoic mole map. So remember, BCA stands for before, change, after. We just have to make sure that the moles before, if you're given mass, you got to change it to moles using the molar mass. Remember, to change grams to moles, you divide by the molar mass. The products we always have 0 of. So if we have some reactants and we have no products, we know that the products get the plus and the reactants get the minus sign. And then notice that the coefficients from the balanced equation with the letter X is what fills up that change chart. So I'm going to do one more limiting reactants problems using BCA chart for you so that you can try to, one more time, wrap your brain around it. So let's just say I'm combusting sucrose. I'm going to start with 10 grams of sucrose. If it's a combustion reaction, what's my other reactant? Oxygen. This is where being left-handed comes in not so handy, because I always want to lean my hand on the thing, and I can't do that here. So hopefully the writing will be clear enough for you. All right, you may not know what sucrose is. That's cool. I'll tell you what sucrose is. Like that. This is going to be a combustion of a hydrocarbon. So what are my two products going to be? Water, carbon dioxide. That's not helping. All right, if you remember, the first step is to balance this equation. These are the trickiest to balance. These combustion of a hydrocarbon problems are the trickiest to balance. I always start with carbon. I always leave hydrogen and oxygen to the last. So let's just put a 12 here and see if that gets us any place. And so that means that I have my 12 carbons on the reactant side, 12 carbons on the product side. I'm good with carbons. Let's do this here. 11. Now we have to be careful because we have oxygens in sucrose and we also have oxygens in O2. So we have 24 and then 11 here. Well, let's just marry this 11 with this 11. And we know we need 24, so this will be 12. All right, so my first step is to say to myself, I'm given grams, I'm going to change that to moles. $10 grams of sucrose. A lot of times when they have those big, long compounds, we come up with some sort of abbreviation for it. Believe it or not, chemists are pretty lazy. And I'm going to add up all of this, 12 carbons, 22 hydrogens, 11 oxygens. We get 342.30 grams in 1 mole. So 0.0292146. I'm going to carry a ridiculous amount of significant figures just for effect. Now, the limiting reactant part is the toughest thing to figure out. So I'm going to show you another trick for if that's what's tripping you up is figuring out which one's the limiting reactant. Let's do another trick. You can see that the coefficient in the balanced chemical equation for sucrose is 1. The coefficient for oxygen is 12. So I need 12 times as much oxygen. If I was going to use all this sucrose, what would be 12 times as much. 12 times as much sucrose. In order to have exactly the right amount of oxygen, we'd be 0.3505752 moles. That's how much I would need if I wanted the exact stoichiometric ratio. Let's figure out how much we do have. Remember, you can't ever compare grams to grams. You got to go grams to moles. This is O2, not O2, so it's 32 grams in 1 mole. And I actually have, so this is what I would need. I actually have 0.3125 moles. Do I have enough oxygen? No. Once you say, I don't have enough, should be a red flag and say, oxygen is my limiting reactant. So that's another way you can figure it out. Let's put this in here. So 0.02921. I don't need all of those anymore, do I? 0.3125 for oxygen. I know that it has to be moles, so I'm going to say to myself, I'm not going to put the units in. That's going to cost me more time and make everything a little more messy. Before a reaction starts, I have no products. So because you start at 0, you can't have less than 0. I have pluses here, minuses here. This is minus x. This is minus 12x. This is plus 12x plus 11x. So remember, we already decided that this was the limiting reactant. If you can't figure it out, you can set them both equal to 0 and pick the smallest value of x. But I already figured out that oxygen's the limiting reactant. The other thing is, too, is you could just pick one of them and be like, yeah, I'm just going to throw caution to the wind. If you end up getting a negative answer for how much you have left, you know you picked the wrong one. You can't have negative quantities. Negative signs in chemistry class only refer to change. So that's going to be a source of endless confusion through the end of the year. But just remember that you're talking about change, or you're not referring to a quantity. Okay, so 0.3125 minus 12x equals 0. I solve for x, and I get a value of 0.02604 is the value of x. So now, in order to figure out the after right here, this is going to be 0.02921 minus x, or and I can see it's not going to give me a negative quantity, so I didn't make a mistake. If it was going to give me a negative quantity, that's what would tell me I made a mistake. This is 0.00316. That's how much of this is left. This is the kicker, people. If you do the stoichiometry, like the straight stoichiometry method, this is the one that's hard to find out, is how many moles of the reactant in excess is left over. How much carbon dioxide did I produce? It's going to be 12x. So I'm just going to type in 12 times 0.02604 in my calculator, and I get, what's going on here? $31248. This times 11, so 0.02604 times 11 is 0.28644. So one of the questions that might be asked of you is what is left in the container? What is left in our reaction vessel is sucrose, no oxygen. That's the limiting reactant. It ran out. We also have carbon dioxide. And we have some water. Remember to change moles to grams. You're multiplying by the molar mass. And this is grams. 1.08 grams of sugar left. 13.75 grams of carbon dioxide left. 5.16 grams of H2O left. If I started with 10 grams of sugar and 10 grams of oxygen, this is what I will end up with in the end. I will end up with 1.08 grams of sugar left over, 0 grams of oxygen, 13.75 grams of carbon dioxide, and 5.16 grams of H2O. Who gets the gold star? What are all three of these numbers going to add up to? 20. Now, they happen to add up to 19.99. Anybody know why that is? Yes.
Rounding.
Yeah, rounding, sig figs. We can't carry all of those significant figures with us. Remember how many we started with? Nobody wants to carry all of those with you for the entire problem. So you will end up with a little bit of systemic error there, but that's cool with us. We're not trying to save the world yet, right?